Hello everybody. So I've been getting a few questions about the washer method in particular. So here I'm going through a few of the questions that were generated for me on the Khan Academy practice. So what this question is saying, we're taking this region R, which is enclosed by the y-axis, this horizontal line y equals 4, and the curve y equals x squared, and we're rotating it about the x-axis. So what that means is just here it'll be a circle, right? When we rotate that around, it's going to go more like this. But then all of these are going to create a washer, right? Because we're going to have this part in the middle that leaves that hole there for all of those cross sections. So let me erase that because that's not too purty there. But basically, as you start to make use of this structure, the nice thing about this one, it's being rotated about the x-axis. So remember, it's just the area of the bigger circle, so of the upper radius squared, minus the area of the smaller circle, the lower radius squared, which if we factor out pi is just pi times the difference of the radii, upper and lower. And we're going to have to basically integrate that over this region. And the radii are actually the function. So the upper radius is just the upper function, which in this case is just 4, y equals 4. And in this case is just x squared, which I could simplify to x to the 4th. So that is what I'm going to be integrating. So I'll integrate. Again, I could pull my pi out. It's going from 0 to 2. The nice thing is that this is about the x-axis of 16 minus x to the 4th dx. What I would do right here is just go to my calculator and try to calculate it. So I'm going to my calculator. If you look here, what I have is I put it into my calculator exactly as I had it written. It gives me this decimal thing. The funky thing is I noticed on Khan Academy it asked me for it exactly in terms of pi. So I just divided that irrational answer by pi in my calculator, gave me 25.6. Then I hit math fraction, it told me it was 128 over 5. So that's 128 pi over 5. I put it in and it gave me the correct answer, which is made me happy for that little dingy ding with the star that it gives you. So the next question that we're given is the region R. It's enclosed by a positive x-axis, the positive side of the x-axis, the curve y equals x squared, and the line x equals 2. So we're trying to find the volume of the solid when it's rotated about the y-axis. So it's a little bit different because we're going to be rotating it about the y, which I know means I'm going to have to get these functions in terms of y rather than, x equal the x by itself, the function as x in terms of y. So if y equals x squared, this function would just be, if I take the square root of both sides, x equals the square root of y. For this y equals x squared function. Also, this vertical, or what's to us is this is the x-axis. With this, if we're thinking about it sideways, that'll just be, that vertical line will just be the equation x equals 2. So basically, the x equals 2, if you were to think about sort of taking this and spinning it on its side, right? Because we're going to be rotating it this way, we could just integrate for the y value 0 to 4. Again, I could pull my pi in front, and the upper is going to be the 2 squared minus the square root of y squared dy, which is just going to give me Oh, I thought it was recording, but I may have just done some work without recording. So I'm basically now trying to get the integral, but I'm rotating it about the y-axis. So what I did here was I took my function, my y equals x squared. I took the square root of both sides, and I got x equals the square root of y, because I'm trying to now plug them in with my function sort of in the opposite way, with an x value in terms of y, because I'm going to be integrating along the y values. And I'm just going to do, in this case, my upper function is this it's this vertical line, which is just x equals 2 minus the square root of y, which is my other function. So it gives me this quite simple integral, very similar to the structure of my last one. Let me go to my calculator and calculate it. And what you see here is I can even do this with y's here. And again, it gave me my exact answer, which would be this, but I think it's going to ask me again for it in terms of pi. So when I divide by pi, I just get 8. So my answer is just going to be 8 pi. And when I press that and check it, it gives me my answer. On that one, you could have done it in terms of x, and you would have gotten the exact same thing. You would have just had to replace those y's with x's. The next one is a little bit different, but you're going to start noticing that the structure is going to be similar throughout. I have a region R enclosed by the y-axis, the line y equals 2, and the curve y equals the square root of x. So in this case, it's just my integral. This is again rotated about the x-axis. So I'm using my x value, 0 to 4. And I'm just going to take the difference. The upper would be the y equals 2. 2 squared is 4. I'm just going to skip a few steps. Square root of x squared is x dx. Plug it into my calculator. Let's take a look. I'm pretty sure that this is actually the same value as before, right? 25.13. So when I divide by pi, which you can't see me doing here, I indeed get 8 again. So this is just 8 pi. If I go in and put my answer for this one, let me check. Yes, I got it. And I believe I'm on to my last question, number 4, which looks a little bit more challenging here. But what I'm starting to feel like is that the structure of these are quite simple. So this one's going to be rotated about the y-axis, as you can see. It's a little misleading they put this here, because we're not going to need to know the x interval, but I don't know, this just maybe they're trying to throw us off a little bit. So this one, I'm going to have to, so it's going to be between this curve is going to be the right curve, and this will be the left curve. This left curve is just going to be the line x equals 3, which is already in terms of x. So I'll have to do pi times the right curve minus the left. So we know this is already going to be 3 squared. The thing that's tricky is we're going to have to get this in terms of x. So y equals 2 times the square root of x minus 3. I'll divide both sides by 2. I get the square root of x minus 3. I'm going to flip them here. Equals y over 2. Square both sides to cancel out the square root. I would get, I could even just leave it like that if I wanted. I'll just get x minus 3 equals y over 2 squared. And then I'll add 3 to both sides. And so the function I'm going to need to use, I could simplify, I guess, y squared over 4 plus 3. That's what's going to have to go in that first spot. So maybe I'll erase my minus 3 squared, and I'll just put y squared over 4 plus 3, all being squared, minus the 3 squared, and that's going to be dy. And we could see the interval here. Well, this is y equals 4, so I'm going to be going from 0 to 4 on this integral. Again, I'll go to my calculator and let my calculator do the heavy lifting at this point. So my calculator, I've actually just plugged all that stuff into it. I got 140.74 irrational. If I divide by pi, it's 44.8, and the calculator turned it into a fraction. So it should be 224 pi over 5 would be the volume of this funky shape. Let me try it on Khan Academy. Pi divided by 5. And we got it. So I hope that this was helpful for people having trouble with that Khan Academy assignment that was due yesterday. Of course, you can still complete it. I'm going to try to get another video in soon about rotating about other axes if you feel as though the Khan Academy videos aren't helpful enough. Stay tuned, and much love to everybody. Hope everybody's hanging in there. Don't hesitate to reach out, even if it's just to check in and see how I'd love to hear how everybody's doing. Much love.